This is numbers 3 through 5 on the study guide. Number 3, it says find the measure of the indicated arc or angle. So we've been asked to find the angle BAC. There's your angle measure, so we know that they're asking specifically for this angle here that I just starred. Let's apply what we learned about central angles. A central angle has its vertex here on the center. So there's the angle right there, BOC. The angle is right on the center. A central angle and its arc, notice that B and C are the endpoints of this BOC. B and C are the endpoints, so the arc that goes with it, arc BC, is going to be the exact same measure as the central angle. So this has to be 132 degrees. Now, I'm going to highlight something for you to see another angle that's involved here. Look at BAC. And look at where its endpoints are, right here and right here. Those endpoints are still on BC. So this angle, BAC, is what we call an inscribed angle. Its vertex is on the circle, and its two endpoints here are B and C. So this arc, BC, goes with it. That means this arc of 132 degrees goes with it. There is a formula that allows us to say that the angle, when the vertex is on the circle, the inscribed angle, vertex is on the circle, this angle measure is half of its arc, half of the 132. 132, you're going to divide by 2, or you can do times 0.5, and you're going to get that this is going to be 66 degrees then. So again, the inscribed angle is half of its arc. Half of BC is half of 132 is 66 degrees. This one, number 4, is very similar. If you look here, we've been asked to find BC. Now I'm going to highlight this angle that we're looking at again. It goes from B to A to C. So again, notice B and C are both endpoints on the circle, and the vertex is on the circle again, which makes this 27 degrees here the inscribed angle. That means that this angle is half of its arc, half of the BC. So that means that we have to double this 27 degrees times 2 to get 54 degrees. That's how much BC is, because if BC is 54, half of that is our angle, which is 27. So BC is going to be 54 degrees. Finally, we've been asked here to find BAC. Now I'm going to highlight this angle here just so you can see. There's its endpoint, or its vertex right here, and its endpoints are at BC. So if we could figure out just how much BC is, we could divide that arc BC by 2 to find its angle. The angle we're trying to find is this angle here, BAC, so it's this angle right in here that I just starred. Well, if you look, all I know is that this central angle is 94 degrees. Now, if it's a central angle, remember, its arc is going to be the same measure. So arc CD is 94 degrees. But if you look very carefully, BD is a diameter because it goes through the center. So I can find this missing arc here, because if I do 180 degrees, that's from B to D, BCD, minus the 94 degrees, whatever's left is going to represent BC. So I want to do 180 minus 94, and that's going to give me 86 degrees. That means right here, this is 86 degrees for arc BC. This here. And its inscribed angle, look at its endpoints of this angle, vertex is on the circle, and the endpoints of that angle go from B to C, which represents this arc at 86 degrees. That means this has to be half. So, what is 86 degrees divided by 2? Well, that's going to be 43 degrees, which is my answer for the angle BAC.